Hi learners, welcome to ST.JOSEPH'S College. This is BHARATHI from Department of Computer Science. So now we are going to study about another important concept comes under main memory, and that is called contiguous memory allocation. So what I mean by contiguous memory allocation means where the memory management, the data will be stored and be allocated in a continuous form. That is called contiguous, where for any processing that we have to do, right, we need a space to do the processing. For that we need some memory space. So it allocates a contiguous block of memory to each process to get processed, and that is called contiguous memory allocation. So whenever a process is there, it wants to be processed. Okay, process can be anything: opening a file, closing a file, saving a file, deleting something, updating something. Each and everything that we do inside a system, right, we call it as a process. So when a process requests for a memory, a continuous block will be assigned to its side. See, consider this as a memory block, this as a memory block. For do us a particular process, this particular memory block will be allocated to do the processing. Okay, and that too will be done in the sequential order. When this, say example, this is of 10 MB, 10 KB, this is of 10 KB, this is of 10 KB, this is of 10 KB. Okay, so each one will be allocated in the sequential manner, continuous way. So in memory management technique, apart from this contiguous memory allocation, we have another method that is called non-contiguous memory allocation. So in contiguous, right, we have two types. One is fixed partition scheme. Another one is variable partition scheme. So what do you mean fixed partition? Fixed means fixed size will be there. So say example, take this one. Here is an operating system where it has a block of memory is been created, 10 MB, 10 MB, 10 MB. And now comes the process to be executed. And now this is the process of opening something. Imagine, okay, this is the process of saving something. This is the process of updating something. And to open something, I need 6 MB. This process size is 6 MB. So it looks for the memory place where I can do it. So when it get into the operating system, will assign this particular block to do this process. Okay. So this will be allocated. For process 2, this block will be allocated. Process 3, this block will be allocated. But unfortunately, here we have 4 MB unused. 4 MB of space which had to be unused because 6 MB is enough. What about the remaining 4? It is unused. If you take the second process, right, it requires only 2 MB, but here it is 10 MB. So remaining 6 MB will be unused. If you take the third one, 8 MB is okay, but here it takes here it is 10 MB, but it required only 8 MB. So 2 MB is unused. So what happens in case of fixed size partition? Even I fix some blocks, but there may be some kind of unused space will be there. That is what we call it as internal fragmentation, right? Internal fragmentation. Fragment means what? Nothing but the block, right? So internally there will be some kind of blocks which will be kept unused. That unused blocks, when I have so many processes to be done, so many unused blocks will be there, means that automatically reduce the overall efficiency of the memory management unit. So this problem we call it as in fixed partition scheme, right? In fixed partition scheme, we have a problem called internal fragmentation. Internal fragmentation. So this occurs when we does not use all the small memory blocks, right? So that will be a problem for it. Next, we'll move to variable size partition. Variable size partition means what? It is where if I want a 6 MB means 6 MB will be used, the 4 MB will be allocated to some other thing. Okay, so 2 MB comes, 8 MB will be allocated to some other things. So that is what called variable size. Based on the size coming inside, the process comes in. Based on that, the size will be modified. But but here, unlike the fixed size partition, the size of each partition is not fixed, where it can vary depend upon the memory requirement. So what is the requirement? Here it is 6 MB, but here it is 10 MB. So 6 MB will be allocated for this process P1. 4 MB will be fed. So anything which comes with 4 MB means it will be allocated. Okay. Now say example, now it is 4 MB means this remaining 4 MB will be allocated to process P2. This will be allocated to process P1. Right? You understand? Now this 8 MB will be allocated to this one. Remaining 2 MB will be kept. If anything comes for 2 MB, that will be allocated. But here also we have a problem. Whenever we have small gaps, many small gaps are there, means that has to be handled, right? If that small gaps are not used also, that's also same problem. And that problem we call it as external fragmentation. when there are small gaps between memory and making it to allocate for larger process. When larger process come, it will not able to allocate, right? And that problem we call it as external fragmentation. So contiguous memory means what? Continuously the memory block will be assigned to the process. So when I assign, how it can be done? Either by means of fixed size or by means of variable size. Fixed size, what will happen? If I do fixed size, there will be some kind of unused space, and that unused space will create a problem called internal fragmentation. And next, variable size means what? Where I will be allocating varying with respect to the process memory, it will be allocated. But there also what happens? Small fragments will be created. That small fragments will be taken, will not be able to adopt a larger process. That will be creating external fragmentation. External fragmentation. So these are the main issues which we face in contiguous memory allocation. Hope you understood the concept. So next, when we will go to the non-contiguous memory allocation types in the next video. Clear? Thank you so much.